Hi everyone, it's Judy. Welcome back to the OnTrack podcast. Today I have a special treat for you where I'll speak with Dan Beeker, who is the Senior Principal Engineer for NXP. He's going to challenge you to think about EMC and signal integrity in a fresh way that's going to absolutely impact the designs that you do every day. So lean in and enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Wait a minute. Before we get started, we've got some exciting news. Altium has some amazing limited time spring specials that we just have to let you know about. Right now, you can save up to 45% when you upgrade to Altium Designer 19 or add additional licenses. The offer expires May 22nd, 2019, so don't wait. Check out the Altium website at altium.com today to learn more. And now, let's jump right into another great conversation on the OnTrack podcast. Well, Dan, it's so good to see you, my friend. Thank you for joining this morning. It's fun to have you on the podcast.
Oh, you're welcome. Good morning, Judy. It's really exciting to be able to do this and talk with you and share some of our experience.
Yeah, we've had some fun together at AltiumLive. So for those of you that haven't joined us yet at AltiumLive, Dan Beeker from NXP has been with us twice as a keynote, once in San Diego and once in Munich. And his talks are always very popular. So Dan, before we get started, why don't you share with our listeners a little bit about your professional background and your role at NXP today?
Sure. I started out with an Air Force electronics training, and probably the most exciting part of that was to learn how to use test equipment and to solder. And so after I got out of the Air Force, I was looking for a job and was lucky enough to find an opening at Motorola in their microcontroller tools group, Microsystems, and became a test repair technician, and eventually became a group leader and learned all about microcontrollers because I had no background, and the whole industry was coming alive at that point in time. We were working on 6,800 micros. So I was able to drag myself into the engineering side and help with designing tools, and ended up being part of the engineering team for the 68000, 68020 in-circuit emulators. So pretty much really exciting high performance engineering, and had some extraordinary mentors along the way at Motorola, and then ended up moving to the Detroit area as an automotive applications engineer, because I don't have a degree, and there was only one way to get promoted was to go to school and try to get enough hours that they would make that change for me. But I kept getting new managers while I was in Phoenix, and they would always say the same thing: go back to school and get good grades. And then they had a call to move field engineers, so they wanted to have more engineers supporting customers. And I went to the personnel director and said, would you make me an engineer and let me go to the field? And he said, if you can find a job, we'll promote you. And so, wonder of wonders, I found an opportunity in the Detroit area working on automotive, and I got my first promotion to beginning engineer. And now I'm on my 38th year, and I'm a senior principal engineer within NXP. And my tools experience never left me. It's, typically if you learn how to do something most people are afraid of, they never let you stop doing that. So even though I moved to the field to directly support customers, it only took them a couple of weeks before they remembered I was a toolsmith and had me teaching how to use tools and fixing broken tools. And then there were a couple of opportunities in the factory where we needed some instant engineering support, and so I was a zero learning curve addition and worked on a couple of special projects on new and circuit emulators. And that evolved into a little skunkworks business that I run in the Detroit sales office, where I actually design and manage a P&L where we create the missing links in the tool chain to support our customers. So it's been a lot of fun, and I still have a day job as a field applications engineer. But from my work designing tools, as the technology changed, it was no longer a given that you would get good signal integrity and EMC performance by just hooking up the wires.
Right.
And that led me to pursuing how to do good design and manage signals and become compliant, because the other side of that was my customers were having extremely terrible troubles trying to get their products to be compliant. And since we had the microcontroller or microprocessor, depending on the application, we always got blamed. So there was nobody to turn to. And we had hired some external consultants a couple of the times, and they just never came up with a good solution. It was all hit and miss voodoo stuff. And so I took it upon myself to go learn all about good design practices and signal integrity and EMC, and that led to where I'm at today. So it's been interesting, very lucky. I've been blessed with, like I said, some great opportunities and some extraordinary mentors.
And some hard work, the school of hard knocks. I come from that I come from that same school. We graduated from the same University of Hard Knocks there. Yeah. And but it's hands-on learning. You're learning in the trenches, so I think that learning is really very valuable. And engineers today are gone are the days where for most part, gone are the days that a PCB designer may be a separate person from the engineer. There are still those separations, but those roles are melding a lot. I think 60 or 70% of Altium designer customers are EEs. So, there's been, you talk about, that'll lead us right into our talk, is your talks at AltiumLive have been entitled, It's All About the Space. And not only is it a great talk, Dan has written a song, I kid you not, and it's a great song that his daughter sings, and I will share it in the show notes. And he has rewritten the lyrics to Meghan Trainor's It's All About the Bass, and It's All About the Space. It's a great song. It'll burn in your memory, which was his intention, I think. So, Dan, let's just jump right in. What do you mean it's all about the space?
Well, that's the real key to successful engineering. After 10 years of studying and going to classes and arguing with people, and finally coming to some reality that it's energy moving through space, and that whole perception is absolutely critical. If you don't design the spaces, then you really haven't got a lot of hope for success, especially as the technology continues to accelerate into faster switching devices, higher energy movement, that it becomes a challenge to design a three-dimensional space rather than just hooking up the wires, because the concept that the energy is electrons or something that flows in wires is what has led us to where we're at today. In the past, where signals were TTL and they were switching very slow relative to the geometry of the PCBs, it didn't matter what you did. So our perception was that we were doing it right, rather than it wasn't so bad it didn't work. But as the technology changed and the switching speeds increased, the geometries of the transistors were reduced, then suddenly the fact that we didn't do it correctly was starting to show.
Glaring.
We were seeing higher and higher failure rates in EMC. And when I moved to Detroit in 1987 was when the big change from HMOS to HCMOS was going on. And everybody was happy with their HMOS devices, and they could just wire them together and hook things up and put them into the chambers, and everything worked. They would pass EMC, they were functional. And so the silicon companies, Motorola at the time was one of them, wandered out into the market space with these high-speed CMOS devices that were faster, smaller, better, and every module failed EMC. And in hindsight, I can easily understand that because now I'm looking at the spaces, is we reduced the size of the antenna required by an order of magnitude when we increased the reduce the switching speeds by an order of magnitude. So things were switching 10 times faster. It took 1/10 of the size of an antenna. So it went from where a quarter wavelength was more like 20 or 30 feet to where the antenna size or quarter wavelength was more like 2 or 3 feet. And that's what was connected to every single automotive module. There's at least a 3-foot wiring harness. So we gave them a transmitter and they hooked it to an antenna, and guess what? It radiated. And so all these failures occurred, but nobody really took the time to understand what was going on. And even the consultants, I mean, it was just a nightmare for everybody. They were spending hours and hours in the test chambers. We would make small changes and hope it would make a difference. And sometimes it did and sometimes it didn't. And there was just no science to it. And so we were continuing to teach the same circuit theory in school. And all the old timers like me were still practicing circuit theory and fighting to protect it in spite of the fact that we were continually failing.
Right. I remember Rick Hartley, who was one of your mentors, talking about this specific to rise times. But he said there was just a time where like everything stopped working. It's like your world was switched, flipped on its head. And you went from being the smartest guys in the room to scratching your head, but still defending this theory. And I also remember Rick sitting in a class not that long ago, within the last 5 years, Rick Hartley explained how the energy moved through the laminate, which is the space, and my head blew up. I was like, wait, what? Because like in the olden days, because I've been around a while too, we thought of this energy moving through traces like water through plumbing. Like it just moved neatly along. And when he explained it and showed the energy field, I was like, wait, like it was like someone saying, the world's not flat.
Yeah, that was the hardest part for me. Was it took 6 or 7 years to completely unlearn my 20 years of I'm doing it right and I know what the heck's going on, to completely changing my perspective where I think in 3 dimensions now, and I look at the plumbing. I look, where are the spaces? Where did you break the space? So it's, one of the issues I see is moving through the board stack from one dielectric layer up to a higher one. Well, if you don't provide the pipe that goes up through the wall, it's like having a pipe in your basement and a pipe on the second floor of your house, and you expect water to get to the pipe on the second floor. Well, it'll eventually get there, but it has to fill up all the spaces between there. So field energy acts exactly the same way. And we got away with that when it was slower because we had the time to allow it to fill that space. And eventually it got there. And I wire wrapped a 68020 single board computer, and it looked really pretty, but ground was a wire, power was a wire, signals were wires, and where the energy moved, they're in the wires, right?
Right.
And I proved it. It worked, but that's because it was
slow.
ETL.
Yeah.
It was slow relative to the size of the board. There were no long enough structures to be radiating antennas, and everything was what we call inside the lump space. So it was single wave transmission of the energy, and it made it look like what we were doing was right.
Well, you came to this aha moment a long time ago, Dan. So why do you think engineers and designers alike and people like me are still shocked when we hear a talk from someone like you or Rick Hartley? How is that disconnect happening between the physics and our design practices?
It's a little bit confusing, except when I look back at my experience, I just didn't want to believe in geometry. Yeah, geometry can't be important. The geometry of the transistors, the geometry of the space in the board, the distance between the driver and the receiver, it's instantaneous, right? Current flows in a loop. When you turn on a switch, then the electrons start moving in that circle. No, that's not how it works, but everybody thinks it does, and there was all this perception that the energy transfer was instantaneous, that as soon as you turn on a switch, the load sees the energy and everything is good. Well, the problem is, if that was true, there would never be signal integrity problems and no EMC issues.
Right.
It's not a belt in a car. It's like turning on a hose, and the water has to fill the hose between here and the other end, and it takes time. And then having time be something important, energy moves at the speed of light, right? Mm-hmm. That should be fast enough. I'm finding out that it's really, really slow, and we wish energy moved faster. So,
which is it's crazy that we've gotten to that, but
it's that they continue to.
Is it what we're teaching in university still? Why don't we know this?
I think it's the fact that the physics side of the electronics engineering is made to be something that's quite difficult, and it's calculus and Maxwell's equations, and then the other side, the circuit side, is algebra. It's just linear algebra. It's very simple to do the math, and there isn't a really good connection between the science of energy and its reality and what we teach people in how to design and use things. So we don't present the fundamental concept that's missing, is that they don't tell people what they do for a living. And
which is?
We design products that generate, manage, and consume electromagnetic field energy. Not electrons. It's electromagnetic field. And this field has to be in a space. And that part is missing. If they did a better job of connecting that concept between the electronics circuit theory, which has quite a bit of value, to the actual physics of the energy itself, then we'd have people that were going to be a lot more comfortable when they get out and do the designs. But I learned it the other way. My mentors taught me the other way when I was working on system design in the beginning. And that whole thing is, anybody who's crazy enough to believe in fields and geometry and goes back from a class to try to teach this to their coworkers and their peers usually get ignored or ridiculed. And so everybody goes back to the status quo and nothing changes. And they continually do things that cause failures, but nobody seems to really want to pursue why that failure's there. Companies don't allow their engineers to go to training.
Yeah, which is crazy to me, because the world changes so fast, and there's people like you and Rick and Eric Bogatin teaching this. And I remember this kid coming to AltiumLive, and he did a little recording on this kind of selfie cam thing, and he said, I just learned more in 1 hour with Eric Bogatin that I learned in a whole semester at UCLA.
Yeah,
and it was because of what you're talking about, because he was teaching basically what you're teaching. It's all about the space. And I had a friend, John Toussaint, who's passed away now, and he used to say, physics trumps theory. And I like that one. So talking about people like Rick Hartley and your dear mentor and friend, Ralph Morrison, can you talk to us about when you did have that aha moment, which wasn't really a moment, it was years, like how that unfolded and the impact really that mentors had on your life and the way that you look at things?
Well, this is where events happen that they're supposed to, and you just happen to be lucky enough and blessed to have that happen. So it started, I was working on a new project, and it was a pre-silicon emulator, so gate arrays and high-tech this and in-circuit emulator and all kinds of wonderful things, which was my specialty. And I was working with a service bureau in Ohio. And I'm going through the design. I'm doing the schematic capture and the system design, and they're doing the layout. And I'm talking to the lead engineer there, and he's saying, well, you really don't want to make these types of signals to move this way. You want to do this differently. And I'm like, no, we're not doing this differently. This is the Motorola Active Probe interface spec. We've used it for 10 years. It's always been the right thing to do. And you work for me. And he's like, no, what you're asking me to do doesn't do what you think it does. It's really going to make things worse. You need to get some training. And I'm like, no, I don't need training. I got 25 years of experience. What are you trying to tell me? And he says, you really don't get what you asked for here. You're asking me to make some changes to your design that are going to cause it to work worse. And he'd been a tutor. He'd been under the tutelage of Rick Hartley for a few years already. Mm-hmm. So he's insisting that I need this training. And then he said the magic words. He says, you need to go to the training. And there's a really good one in California.
Oh.
And so that was the first aha moment.
California.
I need to go to training, and it's in California. So I went to my manager and said, I need to get some training, and it's in California. And he got, so I went to Rick Hartley's 2-day signal integrity class. 5 minutes into that class, I knew that everything I'd ever designed worked by accident, and I'd never done it right, ever, on purpose. And all I could remember thinking is, I sure hope my boss doesn't figure this out. And so I started hammering Rick with questions, and he finally, about an hour into his class, because I was fairly disruptive because I kept asking questions. And he says, who the heck are you and why are you in my class? And I'd already figured out I was the only systems engineer there. Everybody else was PC board designers. Mm-hmm. And he says, I'm Dan Beeker from Freescale, and I really need to know this stuff. and from that, bloomed a friendship. And then I was so excited about what I learned at PCB West that year. We were getting ready for our first corporate conference, Freescale Technology Forum. And my manager was one of the content committee members. And he had to miss one of the meetings that he asked me to sit in. That was a mistake. So we were getting ready to move to 90 nanometer technology, and my customers were having trouble with quarter micron. And I'm like, this is scary stuff. So I started, when there was a lull in the conversation, we need signal integrity training. We have a responsibility to our customers. We already messed them over with HCMOS, and we need to do something. So they went, okay, smart Alec, you get an hour, put together a panel of experts, and we'll start with that. And I'm like, okay. So I'm sitting there, all right, I really stepped in it this time. And I said, what do I got to do? And I started calling authors of the books that I bought to make me look smart. So I had Howard Johnson's books and Henry Ott's books and all these great things sitting on my shelf. Unfortunately, that same week that we had planned to have our conference, there was the annual international conference in Cambridge or in the UK. So all of these big guns were all going there.
Oh.
And so they at least took my calls because I'm from Freescale.
Right.
And so I finally got to Ralph Morrison's book that I had bought, Grounding and Shielding, and left a message, and he called me back and he said, who are you and why are you calling me? And I said, well, we have this conference and I really like you to be one of my speakers. And he said, okay. So that was the first one. And then the rest of the people, I'm like, okay, I'm going to get some people from the PCB West. So I got Rick and a couple other of the instructors from there that agreed to be part of it. Everybody always talked about UMR and how important they were. So I called there. I found out that Freescale was actually part of their consortium. So I ended up getting a couple of the professors from UMR to come. And then one of my friends was the chief technology officer from X2Y capacitors. And then I found that Lee Hill, who was another one of was a consultant, was a graduate of UMR. So I had the whole gamut. I had Ralph starting as the physics guy talking about science, and then I had a couple of the people from PCB West talking about design, and then the testing was the UMR guys, and then finished up with the X2Y guy. By the time they got done, Ralph was so mad he couldn't sit still. He was jumping up and down going, they've got it wrong, that's not how it works. And I'm like really afraid something's going to happen because he was already in his early 80s at this point in time. And I said, okay, Ralph, let's go have lunch and you can tell me about it. And so he started his journey with me and was teaching me about physics and how important things were, that the energy was in the spaces and not the trace. In fact, his saying is what kind of inspired my song. Ralph says, people travel through the halls, not the walls. Signals and energy travel in the spaces, not the traces. And that's kind of, and then I hired Ralph to come teach classes for my customers. And then I had Lee and Rick and all the rest of us. And every time they would come to teach a class, I would go back and sit through it. And I would just be so confused because I couldn't quite let go of circuit theory. And luckily, Ralph and Rick are both very patient. And finally, after about 5 or 6 years, one of the highlights of my career is I did a talk for Freescale at the Corporate Design Center in Austin. And there were some of my peers, application engineers and design engineers, and Ralph and I were there to try to pitch something to our technology office. But he sat through my talk and he walked up after it, and I'm like, okay, here it comes. And he said, Dan, I think you finally got it. And that was like the crowning moment of my career. And
that's cool.
Once he was there, and then I just continued to apply the idea of spaces and managing the spaces based on the geometry of the switches, and it's proved to be extremely successful.
I remember you telling me a story about somebody you were consulting with, and they had designed the board like 9 times, and they wouldn't take your advice for the same reason. They wouldn't let go of the circuit theory.
Absolutely.
So tell us that story. That was a good one.
Well, there was a customer of mine who had they were in another country, but they had a grant from their government to build a factory in the middle of nowhere. And so this was a radio factory. They were going to design a automotive radio product, and they had, by the time I got involved, they had done a couple of iterations of it, and they couldn't get the sensitivity up. They were having problems with the radio working properly. And so I got involved because it was one of our customers, and I looked at the board and I said, well, you really need to change the way your board stack is, and especially important is where your power conductor is relative to the ground. It needs to be next to the ground conductor. It can't be somewhere 3 layers away.
Right.
And this is really the basic problem that you have. So they went away and did another design, and it didn't work. And I looked at it, and it was the same thing. And I said, well, you really need to change this. Well, we've always done it this way. We don't want to change that. So then I hired Rick to look at the same board. He looked at it, and he told him exactly the same thing. You need to change this part of the design. Your power supply has got a problem. And so they did another one, and it didn't work. And so finally, the design manager actually came to Detroit. We sat down. I showed him what was wrong, and he told him, here's a simple way to fix this. He said, okay, this is good. I believe you. He went back, told his designer to make the changes, and the designer quit because he wasn't going to make the changes.
Oh my.
And at the time, and he was the only person in that location that could drive the tool. I won't say it's one of your competitors. And so it got handed off to another location who'd not been told anything, and they did another version of the board, and it still didn't work. Meanwhile, their customers are getting really mad because they aren't getting the radio they need, but they're having to take delivery on this partially thing. And this company, this is their flagship radio. They staked an entire business on this particular product working correctly. So finally, I ended up actually in that location. I taught a class that some of their engineers came to. I got some heads nodding the right way, went to their site, sat down with the engineers, taught the class again, suggested the changes again that were exactly the same. We ended up having their design was actually in another continent at the time, but we got all together, had a call, and about a month later, I got an email that says, we made the changes you said and it works now. And like, it was that much resistance to thinking about things in the perspective of the space.
That's
which
wild.
Is why I had to find a way to brainwash people by creating this earworm that you're going to let loose on the world in a later today.
I am.
And to try to think about things in that perspective.
Yep.
It's all the difference in the world.
It does stick, that song. It sticks. So, kind of piggybacking on what you're saying, I would say to our listeners that I know Dan Beeker because I know Rick Hartley. And I've had that experience of having my mind blown by what he was saying because it flew in the face of everything that I thought up to that point. And both of these gentlemen have been so generous with their time, and I've sat through their classes and I've learned a lot. And so in respect to mentors, I mean, Dan Beeker just called up Ralph Morrison, who is a published author. So I just want to encourage you to find these gems out there, these people that are happily giving away their knowledge at conferences or even shooting an email. So I've learned a lot from you guys, Dan, out there, you ones that have been at this a while, that this mentorship thing is really important. So it's something that I hope that our listeners will think about doing, is finding some great mentors. And so based on all of this, Dan, all this information, what is a couple pieces of advice you'd give to today's designers?
Oh, that's a great thing to be able to talk about. The first thing is to pay attention. If you're still in school, take the extra time to talk to your professors and connect the dots, connect the behaviors of electromagnetic field, at least on a lower level. You don't have to be able to read Maxwell's equations and understand them. For me, I've got Ralph, he can do that. But to understand that it's an energy movement. And then the other thing is that I found that electronics is a world of threes. And if you can think about that, you can only do three things with electromagnetic field. You can store it, you can move it, or you can convert it into kinetic energy. That's it. That's the entire electronics world. You're either vibrating molecules as you move field next to it, in the case of like lighting or other things like that. You're converting it into kinetic energy as you're driving a speaker or a motor. And pretty much that's the only thing you can do with it. It's like water moving past a water wheel. You can cause things to move. That's all you can do with energy. And then the other thing is that this is not an extremely complicated world for managing electromagnetic field. You get three components. You get a conductor, a dielectric, and a switch. You use two conductors to build a space that bounds the field for storage. If you have a switch, then you can connect one space that doesn't have field in it to a space that has field in it, and it allows the field to move into the new space. And then you turn the switch off, and then energy stops flowing into the new space. It's really simple. So you only have three parts to worry about. This isn't rocket science. This is plumbing. And it's extremely simple. And then when you apply the triplets to the idea of PCB design, board stacks, you've got to start using ground as a planar object within your board stack. Would it be better to use discrete domains where every signal has its own discrete ground conductor at a space that's unique to it? Certainly. that is the most secure way to move energy. But nobody can afford a 3,000 layer PC board. But what we use is we use a common conductor that is common from the source of the energy all the way to the place where you consume that energy, which is next to a common dielectric. So the ground, we call it, and the dielectric next to it have to be unbroken from the source of the energy to the destination. We direct the flow with the second conductor that is the boundary for the dielectric or the space. And then what we do is we use switches to direct which other conductor and which part of the space we want the energy to move through. And that's it. If I need a whole lot of energy and I've got a hose that's good for a gallon per minute and I need 5 gallons per minute, I either need a bigger hose or I need more hoses. It's plumbing. If I need an amp, which is a coulomb per second, so it's a physical entity, and I have a transmission line that's good for 1/10 of an amp, and I try to move an amp through there, something's not going to work right. Mm-hmm. So I either have to make it so that the capacity of the transmission line is large enough to allow me to move a coulomb per second, or I add enough parallel transmission lines that I can move a coulomb per second, because I still need that energy to move. And that whole perspective really changes how effective the board design can be. It will always work. So in a board stack, I use triplets: signal, ground, signal. And signal can be power. Power is just another signal, just that you need more than millicoulombs. You need, tenths or 100 or quarter coulombs. You need a lot more energy, but it's still just a signal relative to the input conductor and dielectric. So you need to be able to see a clear space that's bounded on both sides by conductors from the load all the way back to the source of the energy in all 3 dimensions. And if you can do that, then you have a solid design. So in my board stack, I love using even multiples of 3. So my favorite board stack is a 6-layer board. Signal, ground, signal, signal, ground, signal. So both 1 and 3 in that board stack are automatically well-designed transmission lines because they're one dielectric or space away from ground. So I've got dedicated spaces for energy to move through. Same thing with the bottom triplet. 4, 5, and 6 form a nice place where we've got 2 dielectrics. I just have to remember that when I move from the top triplet to the bottom triplet, I need to plumb in the z-axis. Right. So for every time I have to go down from the dielectric between 1 and 2 or the dielectric between 2 and 3 to the dielectric between 4 and 5 or 5 and 6, I need to have a ground conductor next to the signal via so that I have the space. Otherwise, I'm trying to fill the second floor from the basement with one pipe.
Right.
And it ends up being the same thing. So a 4-layer board is okay as long as you make the 4th layer routed as if it was a single layer board, because it's 2 dielectrics and a signal layer away from ground. You can't get away with throwing extra signal layers and expecting them to find ground 2 or 3 layers away. It doesn't work that way anymore. So the orphan layers, as I call them, have to be routed with coplanar ground. So you have traces in the X and Y that are signal, ground, signal. And that can be ground flood or whatever, but you need to always make sure that each signal has its own space. That there's the ground, which is the return that matches the source of the energy, the dielectric that matches the source of the energy, and then the switched conductor is all you have to worry about. And that's, when you look at it, the job is really easy. 2 things of the 3 are already defined. You've got ground, you've got the dielectric. All you have to worry about is the switched conductor. And if you pay attention to that, you're going to have 90% of the designs are going to be complete at that point in time. The rest are just where you have to manage not just having a unique space for the signal. Then we have to worry about matching impedances, which is, again, making sure the geometry that your energy is moving into appropriately matches the energy that the switch is delivering. So, but that makes it easy.
Well, I love how you teach this in such a plain spoken way that even people like me can track with you and understand it. So thank you so much, Dan. Now, I will share with all of our listeners your video and your slides from AltiumLive, but I know you speak fairly frequently. What talks are coming up for you, in the months ahead?
Well, I'm excited to be part of Embedded Systems Boston again. This is my third time, I think, going there. I'm probably going to be.
When is that?
In May. It's
okay.
Coming up. And then in PCB West in September is someplace I always enjoy being a part of. That was really fun to go from being a perennial confused student to being allowed to speak there. So I'm really
not
excited
only allowed, but a celebrated speaker, might I just add in there.
And be with somebody like Rick Hartley. The only bad thing is, as a presenter, I usually don't get to go to his classes anymore because they're at the same time I'm teaching. So that part I miss, but it's really exciting. There's Embedded Systems in San Jose is coming up. I think it's going to be in Santa Clara this year.
Okay.
And then there's a Drive World Congress that's coming up that's in parallel, and I am presenting at both of those. And then NXP will have their annual event in the Detroit area in October, and I'll be speaking at a couple of classes there as well. And that's called Freescale Technology, or NXP Connects is what it's called.
Will you share with us your calendar so if our listeners happen to be in those areas, they can?
Absolutely.
Okay, thank you.
I'll put together the list of the places that I'm going to be at. And
okay. And any other goodies you have? If we want to share Ralph Morrison's books or slide decks you have, please share with me all the goodies so we can pass that on to our listeners, because I know one short podcast isn't near enough to dive in.
This is a great opportunity to put an early commercial. I've been working with Ralph for the last year and a half because Ralph's 94, and I really want to try to capture his vast knowledge, and we were able to get him into Detroit. We did 3 half-day sessions where we recorded him talking about his latest book, and we're in the process of putting those videos up on the web. It will be pay-per-view, but I think you'll find that it's quite valuable. We're near to releasing the website. I gave you a sneak peek at that.
I did. It looks great.
It's a chance to look at Ralph's history and get a chance to see some of the absolute incredible genius behind this man. He's been ignored by the industry for so long, and it was really sad for me when he told me one day, he says, "You're the only person who ever listened to me." And I said, "I really can't understand that, because everything you've taught me has made me a better engineer and helped my customers," which was my job. I'm an applications engineer.
Right.
My job is to find solutions to enable my customers. And one of the most important things that I found was missing was, how do you design a printed circuit board correctly?
Well, you will please, as you get some of these things up and live, we'll add them to the show notes as you have them available, because I would love to share what you're creating with Ralph with our listeners and our designers. So I love the website, what you've done so far, and the videos there. So please continue to share that with us, Dan. And hopefully you're setting me up to maybe even have Ralph on this podcast. So if he agrees, I would certainly love to share him with our audience as well.
Yeah. That'll be very exciting to see that happen.
Very exciting. Dan, thank you so much. It's always a joy to be with you. I always learn from you, and you're just a fun guy to hang out with.
Yes, thank you. It's all about the space.
It's all about the space, baby. Okay, well, thank you to our listeners. Thank you, Dan, for joining, and thank you to our listeners for joining us again. I hope you enjoyed this conversation with Dan Beeker. Please remember to comment. Tell us what you'd like to learn about so we can continue to put out great content. And thank you again. We really appreciate you. So we'll see you next time. Until then, remember to always stay on track.